Ooh, cluster sizing. That seems interesting. All right, let's jump right in. I bet cluster sizing means exactly what you think it does. It's deducing the size of the cluster based on some metadata that you have. Some things you should think about when trying to figure out the cluster size, like what is your required throughput? Specifically, how much data do you need per second? Secondly, your growth rate. How much growth do you anticipate in your cluster? And finally, latency. How fast do you need the cluster to respond to requests? Let's get into each of these just a little bit deeper. Throughput is measured by data movement per time period. For example, how many gigabits per second you want or you can achieve. With Apache Cassandra, these can be different on reads and writes, so consider them independently from each other. The following things can have an impact on your throughput. Things like your operation generators, such as your users, or how fast operations are generated. Also, how big or how small each operation is, as well as the mix of operations, like the number of reads and writes you have in your workload. Let's look at a real example using our Killer Video domain, which is the video sharing application we use in all of our DataStax Academy curriculum. Let's start with write throughput. All right, let's say we have 2 million users and each user comments 5 times a day. We would end up with about 100 comments per second, which equals 2 million times 5 divided by 24 times 60 times 60 again. Wait, this is math. I hate math. Okay, moving on. Each comment inserts a row, and each row is about 1,000 bytes. What we end up with is that we are writing 100 kilobytes per second. Are you ready for the next example? Let's do this. Back in our Killer Video domain, let's display user comments, which are read operations. Okay, we still have 2 million users. No one joined since I finished the last slide. Bummer. Anyway, they are each looking at 10 video summaries per day. Now what? Ah, yes, you end up with 250 queries per second, which equals 2 million times 10 divided by 24 times 60 times 60. More math, ugh. Okay, let's keep going. We have 4 comments per video, which equals 4 rows per query, which is about 1,000 bytes per comment. You end up with reading 1 megabyte per second, which is equal to 250 times 4 times 1,000. Let's move on to growth rate. So there are some things that you need to think about here. What size should your cluster be to hold all of your data? If you know your throughput, then you have to consider your new or update ratio, how your replication factor comes into play, and plan for additional headroom required when performing cluster operations, for example, a repair. Let's take a look at this example, shall we? Let's say you have 100 kilobytes per second throughput with about 20% write updates. The result of this is a growth rate of 80 kilobytes per second, or 100 kilobytes times 1 minus 0.2. Let's throw some replication considerations in there and see what happens. In this example, we have a replication value of 6, 3 replicas in each of 2 data centers. This results in a growth rate of 480 kilobytes per second, which is 80 kilobytes times 6. All right, one more example, I swear. Let's talk about the need to consider headroom when thinking about cluster sizing. There are cluster operations that require additional headroom, at least temporarily, while they run. In this example, we are talking about anti-entropy operations. Remember, you should only load your disk by about 50% because you're going to need the other 50% to copy data to. This would result in a growth rate of 960 kilobytes per second, which is 480 kilobytes per second divided by 0.5. Let's put this all together. Let's assume you have a node that holds up to 2 terabytes max using SSD. This would fill up a node each month by using the following calculation: 960 kilobytes per second times the number of seconds you have in a month divided by 2 terabytes. Woo! I think we're done with growth rate. What's next? Ah, yes, latency. Maybe I should slow that down. Latency. Okay, how does this affect cluster sizing? It's one thing to figure out what your cluster capacity is. It's another thing entirely to ensure you're adhering to your required SLAs. Make sure you understand what your SLAs are in terms of both throughput and latency. All right, what kind of things can affect your latency? Well, for one, how slow you type. But seriously, the following things have an impact on latency: your I/O rate, the shape of your workload, your access patterns, or in other words, the queries that you plan to run, table width, or what your node looks like in terms of memory or the size of the node, etc. Those things will also have an impact. Benchmarking is key when it comes to making estimates on cluster sizing. Now you are armed with the knowledge you need to get your cluster sized right, at least initially. Remember, though, that requirements will change. You should always keep an eye on your cluster periodically and watch for changes in your environment that indicate a need for growth. Make sure you plan ahead for any future growth you might anticipate. Cluster sizing isn't always about getting bigger, though. Sometimes a cluster needs to be scaled back to save resources or to save money.